Hey, how you doing? This is OXDF, and today I'm looking at the Advent of Code 2015, Day 3, Perfectly Spherical Houses in a Vacuum. This is my series where I'm going through and doing an old Advent of Code in Rust as I try to learn it. So hopefully you can learn something, and I'd love it if you all followed along. And if you do, please post your code in the YouTube comments, and I'll certainly take a look. So with that, let's dive in. Santa's delivering presents in an infinite two-dimensional grid of houses. He starts by delivering a present to his starting location, so I'll definitely need to note that. And then he gets a call on the radio that tells him where to move next, which is either basically up, north, south, east, or west, up, down, left, or right. And after each move, he delivers a present to the house at the new location. The elf at the back at the North Pole is a little too much eggnog, and so his directions are off, and he ends up going to houses more than once. How many houses receive at least one present? And so if the input was just one right, the answer would be two because we have the starting one and the ending one. Here we have the starting one up, right, down, left. So there's actually four, but this one gets twice. And then, for example, here we literally go up, down, up, down, up, down, up, down, which are just two houses. And so, as I've said in the other videos, I've actually already solved this in Python years ago, but we're going to pretend I haven't and do it again in Rust. The puzzle input looks like this. It's just a giant mess of little points in different directions. So let's go ahead and jump into Rust. I'm going to use my Genday script here to go ahead and create my project in Rust, as well as download the input. If you want to see the details of that, go back and check out episode or day 0 in this series, and I went through it there. But we can see here I've got the input here, as well as an initial main.rs that all it does is read the input into data, and then I can work from here. What I'm going to want to do strategically here is read the loop over the characters in a for loop, kind of just like yesterday, actually, in day 2 when I looped the characters in a for loop. And this time I'm going to track, I'm going to need to track Santa's position in like a XY plane. So that's pretty easy. And then I'm going to want to use something to track every time he goes to a position. I need to add 1 to the value with that. So in Python, I would use a defaultdict here with integer values initialized to 0. And so each position I went to, the key would be the position, and I would increment the position by 1. Doing a little bit of Googling, I found this HashMap is part of the standard collections library. And it does a lot of the things I want to do here. It looks like I can create a new one here with this HashMap new function, and then I can insert directly into it with this being the key and this being the value. But the example I thought was actually really useful here was this one for player stats, where down here they do player stats, they get an entry, in this case mana, and then they pass that to the and modify, so they're basically adding 200 to mana. And then they pass that to or insert. And so effectively, the way I read that is, if and modify succeeds, it's going to update the value. But if it fails, because there is no key, then it's going to reach this or insert statement, and it's going to go ahead and insert it with the value of 100. So this is exactly what I want to do. It kind of gives me my defaultdict style of style. So we'll go with that. So let's go ahead and give it a start here. We're going to do a for c in data.chars. So we're going to run this for loop. For each one, we're going to do a match on C. And so, if the thing is go to the right, we will update. And so what are we going to update? Let's go up here. We're going to need some variables here. So we'll do let mutable position equals 0, 0. So we're going to start at 0, 0. We can start anywhere. It doesn't really matter, but we'll pick 0, 0. We'll then do let mute houses equals, and what we saw was, let's go up here, and we have to do use std collections HashMap. I think that's right. So now we can come down here and do HashMap : new. And as I kind of discovered in the last one, if I want to call a function or a method on the houses HashMap, I do houses.method. If I want to get something, this would be like a class method in Python. If I want to just call it on the class itself, that's where I use this : syntax. So I've created a new houses, and I need to do right away, I need to do houses.insert position, comma, 1. So right away, we deliver a present to the first house. So now we're down here. What do we want to do? So we're going to say position dot, and the way we can reference these items in the tuple is simply this is dot 0 and this is dot 1. So we moved right. That's on the x plane. So position dot 0 plus equals 1. Or let's see if we want to go up. That would be position dot 1 plus equals 1. Our spacing look nice. Ooh, extra space there. So then if we want to go left, we're going to go position dot 0 minus equals 1. And if we want to go down, the v character, we can do position dot 1 minus equals 1. And then we always have to cover the base case, or Russ will yell at us, so we can do that. And then we're just going to panic invalid input. And we'll put they like, for whatever reason, we like to put the trailing comma there, and we end that. So now we've moved. After each move, we need to update our houses. So we're going to do our houses, and this is that stuff I was just looking at earlier. So we're going to do houses.entry to get the entry for position. And then we'll do and modify. It's not auto-filling for me, but I'm going to hope it's right. And if we look at, let's see, we'll go back to the example here. This is very similar to, again, in day 2, where I did the map function. It looks like it takes in I sort of define the input variable. So in this case, they use mana, and then they have a pointer to that, or they dereference that value and do their addition or whatever to it. So I don't exactly understand why they're using a pointer dereference here. That's what that star is. But we're going to just exactly copy. In fact, we'll just grab this and paste it in here. And we're not going to call it mana. We'll call it, I guess it's H for which house we're looking at. So we'll get a pointer to house, and we will add 1. And then we want to do this dot or insert. And so if it already exists, add 1 to it. Otherwise, the value is 1. Now, I think actually, now I'm thinking about this prompt, we actually don't need, at least in part 1, to be tracking the number of presents delivered to each house. So we could really just, like, for each house, insert the value 1, and then we're just looking for the length of houses at the end. So we don't actually have to keep how many are delivered, but my gut feelings, especially solving this the first time, is this is the kind of thing where then, like, in part 2, they're going to say, okay, now which house has the most, or what's the position of the house that has the most, etc. So having that kind of data stored here, it doesn't cost us anything extra, and it could pay off benefits later. So so to get part 1, we now have Santa looping over all the instructions, going to each house, adding 1 to the value each time, or inserting 1 if it's doesn't already exist. So all we really need to do down here is do houses.length, and I think we're going to be good. Let's cargo run, see what we get. 2565. Don't remember what the answer is. Let's go find 2565. So we got part 1. Awesome. Let's see. What is our part 2 going to be? So the next year, to speed up the process, Santa creates a robot version of himself, Robo Santa, to deliver presents with him. They start at the same location, delivering 2 presents to the starting house, and take turns moving based on instructions from the elf, who's eggnoggedly reading from the same script as the previous year. How many houses receive at least 1 present? Okay, so now I just have to sort of track every other one. So I'm going to show you how I originally solved this, and then I'm going to show you, I went and talked to a friend and got some help on it and make it look better. So to originally solve it, I actually just completely looped again. I was trying to figure out how to, well, I didn't loop again, but I came up here and said, so we'll say let Santa equals 0, 0. We're going to define a Santa position, and oops, we're going to need that to be mutable. Mute robot equals 0, 0. And then we'll say houses dot, oh, sorry, no. We'll say let mute houses 2 equals HashMap new. So we have our second HashMap basically. And now we're going to come down here, and instead of just doing C, now we do care about position. So we're going to say dot enumerate like that. And so now I will be the position in the instructions. And so we can say down here, if I, let's see, mod2 equals 0, so that means we're going to move Santa. We'll do match C, and then we're going to paste all of this in, basically. We're just going to grab this, we're going to paste it here, we're going to fix the tabbing, and then for each of these, we're going to say Santa. So Santa moves. And then we'll say else, and we'll grab all of these again. And again, anytime you're copying and pasting like this, you're probably doing it wrong. So we're going to fix this after we solve, but this is how I initially solved it. And this is the most clean, or I guess, I don't know if clean's the right word, but it's like the most beginner way to do it for sure. I left my match off. So like that, and then we need to tab these over. Okay, so we're going to loop over the things. We're going to, part one still solves the same way, but this time, if I divides is even, we're going to move Santa, else we're going to move the robot. And then after this, we need to, still within this else, houses 2. And again, we can just steal this exact thing here. So we'll grab this. And now, except for we don't want to do Santa, we want to do, or we don't want to do position, we want to do Santa. Let's grab this whole thing. And for down here, we'll add this, and we'll do robot. Okay, I think, and so then down here, we just, for part 2, houses 2. And I think this will run. Let's give it a try. Oh, we got some errors. Okay, let's see where we are. HashMap houses 2. What line are we at? 52. Oh. Because I didn't type the length. It's trying, it doesn't print hash, it's not printing nicely. So let's try that again. All right, 2639. Let's see if we got it right. We got it right. Okay, so it worked. Now, this is like, we're done, right? We got the answer. We could stop here, but again, since the goal is to learn how to use the language, I want to try to make this a little bit cleaner. And so what we're able to do is, instead of just having these two, we can also do let mut current, and we're going to make this a mutable u32. So we make this a pointer. So this is a mutable pointer to a tuple that is of u32. And so this right here means I'm making a pointer. And there's a great Stack Overflow post, which I'll include in the references here, that shows, so like, why do I need mutable here and mutable here? So this mutable says I can change current. I can make current point to different things. So I can, and that's important because I'm gonna have it point to Santa, then point to robot, and then point to Santa, and then point to robot. This mutable says, with this pointer, can I change the value here? Can I modify the position, which I also need to do. So both of those in this case I need. So that's what that does. And now let's go down here. We can come in here and we can say current. We'll say yeah, we can do it this way. Current equals if I mod 2. And then we'll say a mutable pointer to Santa. So if I mod 2 there, else a mutable pointer to robot. Like that. And so now current is going to be pointing to the one we want to move. And so now we can come in here. In fact, we can get rid of all of this. Let's see. Let's make it really tight here. We want these still are going to want to update houses. We're going to update it with current. And now instead of we need to put it in here. So we'll do like this, position like that, and we'll do current.0 plus equals 1. Now like that. And so we're gonna have to do this for each of these. So this will take just a second, but you get the point. Dot one plus equals one. We got the tricky part here is you gotta remember to change all these to semicolons now and put the commas at the end. But again, not the end of the world. So current 0 minus equals 1, close comma, and then last one, oops, let's see, semicolon, current dot 1 minus equals 1, semicolon, close. And then we panic it. So now on each loop, we read the thing, we update. For part 1, we're updating position. For part 2, we're updating whichever one we're currently pointing to. And the compiler is smart enough to know that current is a pointer. So when we use this, position is actually the tuple itself. Current is a pointer to the tuple. But the compiler knows that. So it's smart enough when I do current.0 to know to dereference that pointer and go in. And that's not quite clear to me why I need to. I might have to dive in and actually go into GDB and see how these are different, but we're not going to do that in this video. So I think we're good there. And now we're just, so we update the position of current. We then do that. We might be done. Let's see how it looks. Cargo run. Unexpected closing delimiter. Where am I? 50. Bet I missed something somewhere. Let's see. So did we not close our for loop? Or I think I closed our for loop twice. Let's see. This is where having this large font that's readable on screen just hurts us. We got these. These seem to match. We close the match. That matches the match. What is this? I bet you this is not supposed to be here. Let's get rid of that. I bet that's it. Oh, expected a bool found a use size. So what we mean to say is if that equals 0, in Python I can do that on my own, but can't. That's so if I equals to That's interesting. I did not expect that to fail. What's looking wrong here? If current equals if I less than 2 is that mute pointer to Santa, else pointer to robot. That looks right. It was mutually borrowed here and at the previous. Was mutably borrowed here and in a previous iteration of the loop. Well, for one, this is not the problem we're having right now, I don't think. But we do need to add houses2.insert Santa, comma 2 here. I think that probably didn't bite us the first time but it could have hypothetically if they never got back to this. That's not our problem here. Can't find houses. No, houses 2. Let's run this. Okay, we're getting, okay, so expected tuple found mutable 33, 32. Wonder if this is supposed to be I32. Huh, that's bizarre. Let's see, let's check some more things here. What else could we look at? Current equals oh, I bet I have to dereference that. I do, because it's a point. So I just went on this long thing about how it's smart enough to tell, but here it's not smart enough to tell for that syntax. So let's try that again. There we go. I'm not sure what was giving me the error above, but it seems to have sorted itself out. So what I fixed there was down here, current as I went on a spiel about, current is not the tuple, it's the pointer to the tuple. And so when you want to say, take a pointer and say, get the thing it points to, that's where you use the star. And the star, that basically then says, get the tuple itself. Up here, it doesn't really matter because the compiler is smart enough to figure that out. Down here, it does, because what's happening here, when you call this entry, HashMap is hashing, is taking your object and creating a hash of it. And again, exactly how it hashes it doesn't really matter, but it has to be able to hash this object. And so a pointer is not really going to be hashable in the same way when it's expecting tuples for the hashing, and then it's getting a pointer. It was unhappy about that. So there we go. 2639, I believe, was the right answer. Where's my Chrome window? Okay, that was correct. And I wonder if there's anything else I wanted to talk about. No, I think that's it. So thanks for hanging around on this one, and hopefully you learned something, and I'll talk to you next time. Bye.